All right, the clock's ticked over. It's time to get started. So we're here to talk about VMM networking. I hope all of you are in the right place. We have so much information to cover that we split it into two sessions. This is part one. And as I mentioned, the schedule had it backwards. They scheduled part two first for some odd reason. But I will be going over part one first. And we've got a lot of stuff to cover in the next essentially 3 hours. How we're going to break it up. In part one, I'm going to really introduce VMM networking concepts. I'm going to talk about what we did in SP1, since that's really what's out in the market now that you can use in production. And then I'm going to talk about how you set up your data center essentially from scratch. If you're starting with a brand new installation, what are the steps that you go through and what are the types of questions that you're going to run into and need to answer? I want to give you all the information you need to be able to answer those questions. Along the way, I'm going to mix in some of the information about what's new in the R2 release. How many of you have downloaded and installed R2 already? All right, a few of you. Excellent. Glad to see that you're jumping on that right away, using up the bandwidth in the convention center, so that's good. And then we'll take a break. There's a 30-minute break between the two sessions. That break, you can take a siesta, rest up, because then we have another hour and 15 minutes for the part two session, where I'm really going to talk about hybrid networking and how we enable that with network virtualization. So I'm going to use the setup that we built in part one, and I'm going to set it up to use network virtualization, set up a network virtualization gateway that's new in R2, talk about all that stuff. I've got Charlie Wen from the core networking team in Windows, who's going to come out and talk for a little while in that session as well, to talk about some of the internals of the network virtualization gateway and how it works inside. So there's a lot of good information there too. So let's get started. We're going to start by talking about, what's out there in quick recap of SP1, what you currently have today in production. When we started with SP1, we really broke it down into two categories of features, largely based on what came available in the Windows Server 2012 release. We broke it down into connectivity, so really make it so that you can define the type of connections that you need between VMs, and making sure that where you need isolation, you get that isolation. We want to make sure that it can be multi-tenant. We want to make sure that tenants can bring their own IP addresses so they can talk to each other using their own address space. And so we introduced this concept of what we call a VM network. It's a layer essentially on top of your fabric that lets you define for the VMs their own settings and obscures what the actual underlying infrastructure is from the actual tenants of your environment. It's really kind of a way that a VM abstracts out the hardware, while a VM network abstracts out the network from what the users actually see. Now, the other broad category of changes we made in the SP1 release is all broken down under capability. Now that you have your connection, you know what VMs can talk to each other, how can they use that connection? What kind of bandwidth controls do they get? Are there optimizations that you can use in the hardware? Even things like teaming for reliability, making sure that you have a robust environment. Now, with all these settings, there are so many settings available in Windows Server, and when you bring in extensions into the mix as well, you don't want to configure all of these individually on every host. So we introduced this concept of a logical switch. And the logical switch is really your central place where you define settings for a Hyper-V host virtual switch, and then you can reapply those settings over and over again. So I'll be talking about these concepts as we go through and show you how to set them up and use them. The other thing we worked on in the SP1 release is building a partner ecosystem. We really did a lot of work to make sure the partners out there that are building extensions for Hyper-V virtual switch and gateways and other load balancers, that they're integrating with VMM. So well over half the partners you see here are integrating directly into VMM, building extensions for VMM, plugging into our extensibility model and making sure that they work tightly integrated into the environment. So you've done a lot of work there. I'll show a few demos from some of these partners as well throughout these sessions. All right, so let's get started. We're going to go through and we're going to set up from scratch, VMM, play the role of a data center administrator and get things going. But where do you start? What is step one? And how do you figure out what you need to do? As you start to do things, you're going to have a lot of questions, right? The primary one is how am I going to do isolation, especially if I have tenants that come and go. I have a very dynamic environment. I need to figure out how I'm going to do isolation for those tenants. At the same time, you need isolation for your own infrastructure to separate networks, whether it's for quality of service, broadcast boundaries, or security reasons. you need other types of isolation as well. You want to make sure that whatever you set up is reliable and robust, so that if there is a failure of a physical switch, those are known to fail every once in a while. Your VMs can continue to communicate on the network as if nothing really went wrong, other than maybe a degraded performance. So, as part of this session, you're going to learn how to answer these questions. And as I said earlier, I'm going to make sure that you're aware of what's new in R2 along the way. To see what we changed as well. So the basic steps that we're going to go through, the first step, the best way to get started is to plan your network and design it out. Draw it out on a napkin. You can draw it out in Visio, whatever tool you want, to first identify what your networks are that you're going to need to communicate with. What VLANs are you going to need to create if that's what you're going to use for your isolation. So you know that up front, because these things are really hard to change once you actually get VMs deployed or hosts using these VLANs and your switch is configured. You generally don't want to change those because you'll have downtime when you do that. So you need to plan up front to make sure you get it right from the beginning. Once you know generally what your network's going to look like, as far as who needs to talk to who, then you start to look at what hardware do you have available to do that. What hardware do you need to get? What are the optimizations you have available that you can use to make sure everything performs optimally? Sometimes that'll impose some limitations. We'll talk about that as we go through this. And then you may have to iterate back on your design if there are some limitations imposed by the hardware and some of the optimizations. And then finally, once you have all that ready, then you can go into VMM and actually model these objects, these networks, configure your hosts, and actually create tenants that can use the network and deploy their workloads. So it's really the last step is the VMM configuration. If you do everything else up front, then VMM is actually pretty easy to model that design. So let's talk a little bit about this design. What are the types of networks that you're going to have to represent in VMM? Well, I always like to start with what are the networks that come into my data center, right? You start with, perhaps if you're a hoster or an enterprise that's giving access to the public internet, you'll have an internet connection, maybe a DMZ type network that you want to keep separate generally from your corporate network. Now, you don't have to if you are building a private cloud. Then your corporate network maybe what actually gives your VMs access to the outside world, and these would generally be the same connection, but they don't have to be. So we're going to treat them as if they are separate networks for today. Now, once you have a corporate network, which your admins are on, that's what they're going to use to essentially talk to the rest of the infrastructure. So they are going to need a connection into VMM, but then VMM and all the other servers in your environment need their own network to be able to talk to each other. You generally don't want your average corporate employee going and poking around in your data center. So you create a separate network just for management. And that's what VMM will use to talk to the Hyper-V hosts, and talk to SQL, and what other components we use to talk to VMM is that management network. Hosts will need their own networks for doing clustering, live migration storage. You generally carve those out separately to make sure you get the right quality of service. And then finally, if you do have a multi-tenant environment, you're going to want to have networks for the tenants so that they get their own isolated network that's separate from the other tenants, so that tenant 1 can't talk to tenant 2, and they maintain that isolation. Those will be connected to the public internet or to the corp network if it's a private cloud through some sort of a gateway. We're not talking about a technology here yet, but just know you have to have some kind of connection to get out, and that's generally represented by a gateway. And finally, you want to provide self-service for your tenants. If the tenants are coming in through the internet, they'll use the Windows Azure Pack to get that self-service. They can create their own networks and create their own VMs in their own tenant environment. So this is kind of the environment that we're going to set up today, and we're going to figure out how to model in VMM. So when you look at these networks, the first question is, how are you going to do this isolation? You have a number of different technologies available. The key things to note here, though, is that your data center networks, they don't change very often. In fact, they should never change once you've actually deployed them, other than to add additional VLANs, perhaps, as your environment grows. But the VLANs you've already deployed, the subnets you've already created, you're generally not going to rip those out and replace them. You're not going to delete those on the fly. But tenants, on the other hand, they're very different. Tenants, they come and go. You're going to be creating tenant networks and then deleting tenant networks as workloads are created and workloads get deleted. Or if you're a hoster, as different customers come in. These tenant networks are going to be very dynamic. So you have to think about that when you're choosing the type of isolation you're going to use. Fortunately, VMM has a variety of methods that can be used to isolate these networks. Physical separation is still common today. A lot of our customers want to keep the tenant networks physically separated from their management networks and their corporate infrastructure. We're seeing less of that as we go forward, but it still is around. VLANs are the primary method for isolation, whether it's for security reasons or for limiting the broadcasts. I think most of you should be familiar with how a VLAN works by now. It's a very mature technology. And then PVLANs are a variation of VLANs to work around some of the limitations of what you get with a VLAN. I'll talk about all these in a little more detail in a minute. And then the new way of doing things is with network virtualization. This is where you essentially create a virtual network on top of your physical network in much of the same way you create a virtual machine on top of your physical machine. That virtual network has its own address space. It has its own isolation that's completely separate from your physical network. And so that really gives you an ability to create these dynamic networks that come and go. There's one other type of isolation that we support, and we call that external isolation. If you're using a forwarding extension in the virtual switch, those extensions can actually implement their own isolation. They may use a variety of different technologies. We actually don't care what technology is used underneath. We just give them the ability to basically surface these networks into VMM, let VMM then make them available to the users, or let the tenant users create their own networks. We just pass that information to and from the forwarding extension, let the forwarding extension then realize those isolated networks. So the important thing, though, to remember about this is despite all these different technologies you have, by putting the VM network layer on top, the actual tenants and the people creating the VMs, they just see the VM network. They don't see what your fabric is made of and how it's actually configured. So this isolation actually really helps in a multi-tenant environment. I'm not going to go too deep into VLANs. We all know what they're for. Many of us don't really like using them. They're very limited in what you can do because you have to actually go in and reconfigure your switch to create VLANs. There are limits on how many VLANs can be in a switch before their tables get filled. Lots of limitations of VLANs. But they are very mature technology. They work well once you get them set up. So they're going to be around for a very long time. PVLAN is a variation of regular VLANs where you essentially use a pair of VLANs to provide additional isolation without using a VLAN for each unit of isolation. And there are essentially three modes that a VM can be connected to when using a PVLAN. There's a promiscuous VM. This promiscuous VM can talk to any other machine on this PVLAN pair. It's used for infrastructure services, for gateways. It could be used for an iSCSI target, for example. And then you have machines on the secondary VLAN that are either isolated or they're in community mode. Isolated means that that VM can't talk to anybody else except for the promiscuous VMs. Whereas community is a little different. Anybody that's in the same community can talk to each other. Now in VMM, we only support creating VMs of type isolated, so that VMs that are isolated, so that you can create an isolated VM. It can talk to a promiscuous VM, but we can't create those promiscuous VMs from within VMM. You can get simulation of a community in a lot of ways by actually using network virtualization on the back end of a PVLAN network to basically connect your isolated VMs together. And that way you're actually creating a type of community using network virtualization. When we talk about network virtualization, since it is still new, I'll give you a little overview of how the technology works. You have a physical network that your hosts are connected to. They have their physical address space that they use to send packets on the wire. And they use a gateway that connects them to the rest of the network. This gateway is a special gateway. It's called a network virtualization gateway. The reason why it's needed is because the VMs that are actually on your network, their packets as they go on the wire get encapsulated because these VMs need their own address space. They can't be used to send the packets on the wire. So these VMs encapsulate their packets, they get sent on the wire, and the network virtualization gateway is what removes that encapsulation for routing eventually to a physical network. Because these isolated networks are great up until you need to get outside somewhere. So you have to have a gateway that does that. So the virtual space that the tenants get to use is called the customer address space. Each tenant gets to define their own. The address spaces can overlap within your data center. But you do have to be careful at the point you do route them outside. If you're just doing regular forwarding through a gateway, then the packets going through, the different networks going through that gateway can't overlap in their address space. At the same time, if you're using a VPN connection to your on-premise network, you have to be careful about what address space you use as well, because you need to be able to route those packets in your on-premise network as well. The provider address space is what's actually used for the hosts. And then basically when a packet comes into the environment, it goes through the gateway, gets encapsulated so it can get sent on the provider space, and gets sent to its actual destination. And the whole point of the gateway is to make sure that these packets get on the right network where they belong. Last thing I want to talk about is no isolation. That's one special type of VM network that we have. We actually you'll still use them quite a bit. I'll show you how to set those up for your infrastructure. You'll be using VLANs underneath, but this no isolation basically says, give this VM direct access to this logical network, regardless and wherever you place the VM, we'll pick the right settings for that network. It's really needed partly for upgrading from 2012 to VMM SP1, because before SP1 we didn't have a VM network concept, and you had all your machines connected directly to the logical network. So by having a no isolation network, we can upgrade those machines without losing any capabilities. So in general, where should you use which type of, the different types of isolation? Your infrastructure networks, because those don't change very often, you're going to be using VLANs there for a very long time. So you'll use VLANs whether they are individually isolated VLAN networks, or you have a no isolation where you have multiple VLANs underneath a single logical network. Those are great for infrastructure. PVLANs are great when you have machines that you just have a single machine that you need isolated from everything else, such as behind a load balancer. You can have a common load balancer backend network that you connect your VMs to, but then those VMs, even if they're from different tenants, can't talk to each other, but they can share that load balancer as the front end. Same thing with things like iSCSI targets. Those are good uses for PVLANs. And then tenant networks. We really see network virtualization and external isolation as the way, going forward that you're going to be creating your tenant networks. Now, you can use VLANs for tenant networks. You can create you can basically assign a VLAN to a tenant network, and I'm going to show you that. But we think going forward, you're going to be doing that less and less as network virtualization becomes more mature technology. Last thing I want to talk about as far as planning goes is your address spaces. Each network is going to essentially have its own address space, and who defines it depends on what network it is. For example, your corporate network will come from your corporate IT. Your internet IP addresses, your addresses that are routable on the internet, will come from ICANN. They dish them out. They're getting very expensive for IPv4. And then your data center networks, if you organize things correctly, then your data center can actually define its own address space. It's independent of everything else. It's up to you to decide if you want to do that or if you want to bring your corporate IT space into the data center. And then the key thing to remember about tenant networks is that the tenants will generally define their own space, if you're a hoster in particular. When a tenant comes into your environment, they're going to want a address space that connects them back to their on-premise network using the address space that they're familiar with. Now, generally throughout the product, we support DHCP and static addresses for VM deployments, and also IPv4 and IPv6. We have a requirement that wherever we support IPv4, we have equivalent functionality with IPv6. Let's talk a little about the hardware that you have to work with. There are a number of optimizations available depending on what hardware you have. SRIOV is one of the types of optimizations, a type of network card you can get that gives you this capability for the VMs to essentially bypass the virtual switch. It really gives them a lot of performance because you're going directly to the network adapter. The downside is you're bypassing the virtual switch, and essentially you lose all the bandwidth controls, all the extensibility. Network virtualization has to go through the switch. So you lose a lot of capability. So it's really limited in what VMs can use it. So it's really those that need a very specific level of performance. We do support it through VMM. You can enable it on a port profile and use it with your virtual machines. VMM, though, is limited in its ability to place VMs that use SRIOV. We aren't aware of which hosts have SRIOV. So when you place a VM, we'll try to get SRIOV. If the host doesn't support it, then the VM will be placed. It'll still get its network connectivity, but it won't get the SRIOV performance that it needs. So we degrade gracefully in that case, but something you need to be aware of. So generally, you'll group your hosts that have SRIOV capabilities together within a host group so that placement stays within that host group. Another type of optimization I want to talk about is RDMA. This is something that's becoming more popular because it gives you really high performance access to storage through SMB3 file shares. So if you're storing your VHDs for your VMs on a file share, RDMA gives you really high performance to those VHDs without using a lot of CPU on the host. There are limitations, though. When you have an RDMA adapter, you essentially can't use it for a VM's own communication. It has to be essentially dedicated to storage and other management traffic. You can't create a team out of these RDMA adapters, and you can't create a virtual switch on top of them. So they're really dedicated for host use only. So now when you think about these types of adapters, what are the types of ways you can configure your host to use them? Historically, we've seen a non-converged configuration where you have a number of 1 gig adapters that are dedicated to a specific function. You have some that are dedicated to live migration, some that are dedicated to clustering, so that you can apply the necessary quality of services that you need for each of these functions. And then if you need to team and have redundancy, then you need to essentially double those where appropriate. Wiring becomes very difficult because now you have a lot of wires going into your machines. And with 10 gig adapters becoming more and more available, more cost effective, you don't want to dedicate an entire 10 gig adapter to just management or cluster heartbeat. So what we're seeing is a trend going towards what are called converged networks. The idea that you take these adapters with high amounts of bandwidth, you combine them together, and then you create virtual adapters on top of those in order to actually get the quality of service you need. One common way is to actually create the team, send one pair into the virtual switch, and then another pair gets carved out on what are called team interfaces. And if you're using RDMA, you have a small number of adapters. So we're commonly seeing machines that have 4 adapters, 2 that are RDMA capable, 2 that are not. You'll use the 2 that are not RDMA capable, feed them into the vSwitch, create vNICs for management and other host functions, and then the VMs will use those 2 NICs as well. The RDMA adapters stay dedicated to storage and live migration and clustering because you can't have that team or vSwitch. The other thing you need to think about when setting up your data centers and how you hook up your Hyper-V hosts is how are you going to get redundancy once you get outside the host. We know you can do teaming now in the host, but when you go outside, you don't want to plug these teamed adapters into the same physical switch because then if that switch goes down, you lose all your connectivity. So you need to make sure you maintain multiple paths throughout your network as you go up and up and up. Talking about how you set this up is a little out of scope for this session. But just be aware that you do want to make sure that you maintain your redundancy as you build your way up and outside into the rest of your data center. Once you get into the host, you then have complete control through VMM of how you then set up the virtual switch and teaming to make sure you have that right level of reliability. All right, so let's get into VMM and actually talk about how you're going to set up VMM. That's why we're all here. There are 2 primary concepts that you're going to deal with when you're setting up VMM. The logical network is a concept that's been around since our 2012 release. The logical network is what lets you model the physical network. We made it very flexible so that whatever types of network you have out there, what VLANs you have, what kind of routes you have between those, you can model that in VMM so that VMM can then figure out which VLAN to assign to a VM, which address space to use for a VM. It's also where we put our static IP pools for the fabric networks so that we have a container for that as well. Now, the logical switch is another main concept that we introduced in SP1, and it's really the central place for your virtual switch settings. I'm going to talk about this in a fair amount of detail because it is new and a lot of our customers are still grasping it. But it gives you a way to essentially do what I call the 4 Cs. It gives you a central container. It gives you consistency across your network, so you can have the same settings applied over and over again. Gives you consistent extensions, and then it's able to enforce compliance. Compliance means that if your Hyper-V host somehow changes, somebody goes in and tweaks it, makes a change to it that they weren't supposed to, we'll detect that change doesn't match the settings you have defined in your logical switch. We'll flag it as being non-compliant, and then you can go remediate, and VMM will actually go out and fix those settings that don't match what we expect in the switch. So let's actually jump into my demo environment and actually set up network from scratch. Show you how to set up a logical network first. Okay, so here's a VMM server. This server is essentially brand new. I set it up just for this session. You can see I don't even have any hosts in here yet. No networking defined. It's basically what you would get if you installed from scratch. Now, the first thing that I always do and I recommend you do is you go to Settings and you go to the Network Settings under General. Zoom in for that. So under General and then Network Settings, you open that up and you turn off this checkbox here that says Create Logical Networks automatically. We have this setting enabled by default, and when you add a host that has an existing virtual switch, we'll create a logical network and a VM network for that switch so you can deploy VMs to it directly. The downside is that every time you add a host, if its virtual switch has a name that's a little bit different, you'll get a new logical network, and you'll get these logical networks popping up in your environment. Over time, it gets very messy, and you generally don't want that to occur. So I always actually recommend you just turn this off right away before you even add your hosts. Hit OK, turn that off. Now I'm going to actually go ahead and add a couple hosts that I have in my environment so I can get that process started. And while those hosts are being added, we'll set up the rest of the networking. I'm going to add my Hyper-V hosts. I need to create a run as account for those hosts. This is my Contoso domain. Okay, so now I have credentials so I can talk to these hosts. I'm going to add two hosts, HV3. So these should pop up here in a few seconds. It'll add these hosts, and then it won't actually set up. These hosts are brand new also. They don't have any virtual switches on them. One of them has a VM, but it's not actually connected. Oh, I know what I did wrong. My run as account doesn't like the way I entered it in. Let me fix that real quick. I need to do Contoso /admin. Okay, let's do that again. All right, now it should discover them after a few seconds. There we go. So I'm going to select those, add them. I'm just going to put them into my all hosts. I'm not going to enable migration right now. So this will run. These will take a few minutes to add. So while those are being added, I'm going to start to create my logical network. So I'm going to create my logical networks in basically a way that reflects that diagram that I showed you early on. I'm going to have a public internet logical network, a corporate network, and a management network that I'm going to use in my environment. So I'm going to start by creating my corporate network. So I'm going to use the Create Logical Network wizard. I'm going to call this my corporate network. And then I have three options. These are actually the same options you have in SP1, but we've rearranged them a little bit. Maybe we think this is a slightly easier way for people to understand what these options are. You basically have a way of defining a connected logical network that basically says that all of the VLANs behind this logical network are routable, and we can deploy a VM anywhere in this logical network. You have VLAN-based independent networks. This basically says that we don't assume that these VLANs and subnets within this logical network are routable to each other. So we're going to treat each one as an individual network. It's a way that you would create tenant isolation using VLANs. And then we have a third option for if you want to use PVLANs in your environment. Corporate network is one connected network. We're not going to use network virtualization right now. And so the next step is you define your network sites. Now, the network site essentially defines the connectivity for each area of your data center because it can vary a little bit. If I actually go and look at what my switch is configured like, this is actually the configuration page for my physical switch. I have VLAN 100 defined for my corporate network that comes in on an access port. But I have some of my hosts have a small number of adapters, and so I trunk my corporate network into the host. So if you look here, these first few here are trunked, but then some of them are untagged, so they're in access mode. So I have some trunked, some access mode. So I need to define a network site for each one. So when I deploy a VM, to the host that's in access mode, I won't assign a VLAN if I need corp connectivity. But if I do deploy it onto one that's in trunk mode, then I will assign the correct VLAN. And VMM will take care of that automatically with the model that we've defined. So I'm going to add 2 sites. I'm going to add one for my corporate trunk. And this is going to be VLAN 100. My corporate network has DHCP, so I'm going to leave the subnet blank. If we're using DHCP exclusively, then we don't need to define a subnet, because VMM will never actually assign an IP address to the machine. But if you are using static addresses and you want VMM to assign them, even if you are using DHCP and you want to have mixed, then you need to put a subnet here so you can create an IP pool. Then I'm going to add one other site for my corporate access ports. All hosts. And access mode, you define that as VLAN 0 in VMM. So whenever you say VLAN 0, it basically means untagged access mode. Okay, so I'm going to finish this. And I'm not going to create an IP pool on here, again, because I'm using DHCP. No need for an IP pool, because I'm not going to actually assign any addresses from VMM. My management network, though, will be a little bit different, though. Management, it's also a connected network. But I'm only going to have one site, because management I expose to every host as untagged wherever it's available. I want to make sure I always have that ability to connect to it. So that's going to be VLAN 0, whoops, not O, 0. And I am going to be assigning static addresses to the machines that I deploy here. So I'm going to be doing 172.17.0.0/24. It's my management address space. And because I am going to be assigning static addresses, I need to create an IP pool on here as well, so that I have all the necessary settings for when I deploy my VM. I know what address, gateway, DNS to assign to it. So that's the site. I can give it a range. I can narrow the range down if I want. So if I do have, for example, a DHCP server on here that's using the first 100 addresses, I can start my static pool at 100. I enter in my gateway. And then my DNS server. Okay. I don't have wins on this network, so I'm just going to finish it now. So now I've created my management network. Next one I'm going to create is one for internet. I'm going to do this one quickly because it's going to look very much like my management network. Internet. Now this one would potentially be using internet routable IPs. So I actually have that on VLAN 105. And I'm using 9.9.0.0 for that one. I'm just going to quickly create an IP pool for that one too. Just going to save time, not enter DNS for now. Okay, so now I have my corporate internet management. The last one I'm going to create is, I do have, if I go back to my switch, I actually do have a number of VLANs that I've set aside for doing tenant isolation. So I actually want to create a logical network for those as well. I'll show you how to do that right now. I'm going to go, quick question, sure. So the question was, which type of network is it that you're asking about? Yeah, so you would create one connected network if these different VLANs are routable between each other. And you don't, and when you want to deploy in one place, you want to be able to, you want VMM to pick the VLAN to use depending on where you deploy. If you actually want to have a specific VLAN, you know that when you deploy this VLAN, you want it to be on VLAN 105 or whatever VLAN you have. Then you would do a not connected network because you want a specific VLAN for this VM that you want to assign it to. So that's kind of the difference right there. That's why I tend to say that for tenant networks, when you're using VLANs for isolation for tenant networks, you would do those as not a connected network. So, oops, wrong keyboard. All right, so this is for my tenant VLANs. And this one I'm going to mark as VLAN-based independent networks, because these are all individually isolated networks. And I'm going to add a site for my tenant VLANs. And I'm basically going to add one of these subnet VLAN pairs for each one of my tenant VLANs within this site. So I'm just going to do 3 for now. I'm going to leave the subnet blank under the assumption that I have DHCP available. If you do have static IPs, you can enter in that subnet. So now I've created my logical networks. So now I have one last thing to do, and that's create a VM network. Because again, a VM can only connect to a VM network, so I have to create a VM network now on top of these. So I'm going to go to my VMs and services section, and it's very easy to create a VM network for each of these. So for my corporate network, I'm just going to create that real quick. And this will basically just say whenever a VM connects to this VM network, it's just going to pass through to the underlying corporate network that we've defined. Internet. Management. And then tenant VLANs. Now, when I do the tenant VLANs, you're going to notice that I actually get some slightly different options because it was set as not a connected network. So here, when I actually create this VM network, I actually get to select which one of the subnet VLANs I actually want to assign to this VM network. So in this case, I'm going to assign VLAN 1000. If I want to treat it as a pool of VLANs, I don't actually care which number I use. I have, let's say, 50 VLANs that I've set aside for tenant use. I can just say automatic. VMM will just pick one that's unused and assign it to this network. And then I can hit finish. This actually is a specific network for tenant number 1. I should actually name that correctly. And so there I've created a network. It basically has VLAN 100 backing it. The tenants don't actually see that. They just see the name. And then you can actually give access to a self-service user or a tenant admin through the access panel. And so what you've essentially done with this VLAN 1000 is you've given it a name, so you know who it belongs to, and you've actually assigned it to them, so they can actually use it now without actually getting access to any other VLAN. So it really gives you the ability to provide self-service usage, even though it is a fabric network. Okay, so I have my logical networks defined. Let's go back to the slides and talk about how we can actually use those now in the environment. Oh, well, before we do that, let's talk a little about what's changed in R2 around the fabric. So we've had an extensibility model that we introduced in SP1 where we could have virtual switch extensions or gateways or load balancers integrate with VMM. Each one was a very specific type of device. You had to add it as that type of device. But what we learned is that there's a lot of overlap becoming more common between these type of devices. You may have a switch extension that wants to know about the network virtualization policy that's available in the environment. We also learned that a virtual switch extension, which we introduced the ability for it to supply logical network information to VMM, there are other types of network managers out there that don't have switch extensions that can still supply that information to us. So what we did was we essentially broke down our plugin APIs for partners to use to make them more granular and then put them all under this umbrella of a network service. Now, we did that for everything except for load balancers. Load balancers are still kind of their own standalone type of device. But everything else gets added as a network service. So if you're using 2012 SP1 and you added gateway or switch extension, you would now add it as a network service using the network service wizard. One other thing that we're doing that's a little different, though, is that we're now also shipping more inbox plugins. So we have an inbox plugin for Microsoft IPAM as a network manager. So if you're using the Microsoft IPAM feature in Windows Server, you can now push that information directly into VMM and interact with it directly. So essentially, the network admin sitting at the IPAM console can create the address spaces and subnets that they want. You add IPAM to VMM, and then VMM will import that in. The VMM admin can then associate those subnets to the right hosts. And then over time, as those addresses get utilized, VMM will report back this utilization over time. Well, also then, IPAM can detect conflicts, reflect that back into VMM. So it's a really tight integration that we've created. For tenant networks, those generally originate from the tenants. And so it only goes one way from the tenant that creates their network. We'll report the information back into IPAM, so IPAM's aware of this usage, and then IPAM can generate reports and do other types of things with it. There's a session on IPAM I encourage you to go to if you want to learn more about this integration. They'll do some demos of the IPAM integration with VMM as well. The other type of extension and the additional APIs that we've added is for physical switch management. How many of you went to one of the overview, either VMM or System Center overview sessions? A few of you. So you saw actually a demo of this. I'm going to show the same demo right now. Basically a plug-in model and how we can interact with a physical switch now. Because one of the things before in 2012 SP1, your knowledge of the network as a server admin basically ended at your physical adapter. You had no idea how the switch was configured unless you actually went and logged into the switch. You didn't know which port your physical host was connected to. You had none of that information. So by making it so that we can talk to physical switches through a standards-based mechanism, as vendors then implement that standards-based profile, we can then talk to that switch. We can learn which switch port is the host connected to for each adapter in the host. We can then get the settings for that port and detect if it matches what we expect. So if those logical networks that I just defined, and I'm in a few minutes going to assign to a host, if it doesn't match what that switch is configured to, then we can flag it as being not compliant, because you're probably going to have a problem then if you try to use a VLAN that isn't available on the port. And then we can actually go and try to correct the switch. We can actually enable VLANs, switch the port mode from trunk to access, and a variety of settings like that. To actually fix problems, give the server admin one layer higher of the ability to troubleshoot. Arista is going to be shipping this in all their switches. I believe they're actually shipping it now. They're implementing this necessary SIM profile for physical switch management. And that's actually the demo I'm going to show you real quick, is how we can actually pull in information from an Arista switch and do the remediation. So I'm going to switch over. I actually have a different VMM server that's connected to an Arista switch. And I have a VM here that I'm just going to try to ping another VM. We'll see what happens. Well, my ping's not working. I have a problem here. Now, I can look at, if I'm using 2012 SP1, I can look at the host. I can look at the VM, see what VLAN it's on. I can look at the host, see if it's configured correctly. But if the problem lies outside of that, I would have been basically stuck. But now in R2, if I actually go look down here at my network service section, you can see I have an Arista switch added to my environment. I can actually go up to my logical networks view and pivot over to the hosts where that VM is sitting. And this is the physical adapter that's connected to the switch. You can see that we actually flagged it as being non-compliant. And we give you a warning here saying that the switch is in access mode when it should be in trunk mode. I can now click remediate. I'm going to move this over while it's working. And what we're going to do is we're going to use that standard-based network switch profile. And we're going to go out and tell the switch, okay, switch yourself from access into trunk mode. And as part of doing that, we do a host refresh, which is why it does take a little while. But eventually, you're going to see the switch over, and the ping will start working because we fixed that that adapter. If I actually go into the properties, I can also show you that we are picking up quite a bit of information from that switch and the switch port. So I go down here to my adapter. You can see that on the switch port details, this is a new node that we've introduced in R2. Oh, there goes the ping. It started working, so the remediation was successful. We show a number of information about the switch port details. And you can see that actually the remediation error actually cleared the compliance as well in the background. So I'm going to cancel out of this. You can see now this adapter is fully compliant. The VM's communicating. And I did that basically by talking to the switch and telling the switch to fix itself using information from VMM. So that shows you a little bit of what you can do with this tighter integration that we're getting with these top-of-rack switches using these standards-based methods. All right, so now we're done with the physical switch. Let's talk about the logical switch and how we actually create virtual switches using VMM. The logical switch gives you a lot of power. As part of a logical switch, we'll create teams. We'll set up the switches in a way that's consistent. We'll deploy extensions to the switch. The main reasons why you wouldn't use a logical switch are really there is more upfront configuration. Obviously, you have to create the logical switch in advance before you add your hosts. And live migrations have to stay within the logical switch, because if you live migrate outside of the logical switch, then the settings could change going to the new switch, and we don't want to risk losing connectivity for a live migration. But generally, we see that a logical switch would span your whole data center, so we don't see that as being a problem. How the logical switch works? Well, if you have two Hyper-V hosts that are connected to a physical switch, in VMM, you essentially define the settings for how you want these hosts configured in the logical switch. So you have a number of virtual switch settings. You have port profiles that define your uplink connectivity. So all those networks that I just created as logical networks, this is where you say, this adapter is connected to this logical network. It's through the uplink port profile. We also have virtual port profiles for defining the settings of the virtual port. So all of those advanced Hyper-V port settings that are available in 2012 and now in R2, you can put those in a port profile and reuse those settings over and over again. So then when you create your virtual switch on the host, you basically say, I want to use a logical switch. We'll use the settings from the logical switch to create the virtual switch. We'll apply the port profile to the uplink. So now we know that this adapter that's connected to this virtual switch is connected to management. And then for each VM you create, for its VNIC connection, we'll configure the port using the port profile that's available. And we'll just reuse those over and over again depending on what sort of settings you need. And then you can apply the same thing to the next host and over again. So you don't have to then reinvent the wheel for every host that you deploy. Now let's say a port profile changes. You can see this one down here changes from yellow to brown. This one here. So some setting in there changed. And so now the ones that were using that port profile are no longer in compliance because their settings of these VMs on the host don't match what's in the logical switch. So we'll flag it saying these are non-compliant. We don't make the change automatically because some of these changes could actually impact the data, the ability for the VM to communicate. So we wait for you to do it when you're ready, maybe during a maintenance window if you know that this is an impactful change. You can then go do the remediation. We'll apply those new settings so that your environment's now consistent again. A few ways you can get there to use a logical switch. You can create one through variable deployment. You can create it through the host properties. That's what I'm going to show you in a minute. We also still support standard switches. So standard switches are essentially the equivalent of what you would get if you created a switch through Hyper-V, through the Hyper-V manager. It's essentially a very basic switch. You can create one quickly without doing any sort of upfront configuration. It's also what you get if you create the switch from outside of VMM through the Hyper-V manager. When we refresh in the host, it'll show up as a standard switch. Last thing I want to talk about, primarily I already talked about VM networks, is port classifications. Port classifications are essentially a global name you can apply to your port profiles. So if you do have different environments where you have different logical switches, let's say in one part of your environment you use a Cisco switch extension or an NEC switch extension, and another part you don't, you can have a port classification that you apply to the same port profiles in each environment, and then we'll apply different settings depending on where you deploy your VM. So it's kind of like the storage classification, but it's for essentially virtual switch settings. So let's go in and create a logical switch and get these hosts connected that I just added. So I'm going to go back to my fresh environment here. Hopefully my hosts have been added by now. Let's see. Yep, my hosts are both OK. So now I'm going to go and I'm going to create a logical switch. Before I do that, I need to create my uplink port profile so I know what type of connections I have. So I'm going to do create uplink port profile. Now I don't need to create virtual port profiles because we create a number of those out of the box. I can create additional ones if I want. I can do that later too. For now I'm just going to do the uplink port profile. So this one's going to be my trunk port. Select uplink port profile. You have teaming settings that will get applied if you're going to create a team. If you decide you don't want a team, then these settings will just be ignored. We now support the new dynamic teaming mode that's introduced in Windows Server 2012 R2. If you select this, though, you'll only be able to use this port profile on a 2012 R2 host. So we have this new option called host default that basically says if you use this port profile on a 2012 host, then I believe we use, I think it's Hyper-V port mode. And then if you deploy onto an R2 host, then we'll use dynamic mode. So it basically lets you have a port profile that you can reuse in a mixed environment. So my trunk port is going to have my corporate trunk, internet, management, and even my tenant VLANs all on one single trunk. So those are all going to be going into one adapter. So I'm going to finish that. And then I'm going to create one more port profile for my hosts that have a dedicated corporate adapter that's in access mode. So this is my corp access port profile. And I'm just going to enable that one site on that one. And now I'm going to create my logical switch to use those port profiles or make those port profiles available. So I'm going to do create logical switch. Give it a name. It's my data center switch. Here's where you would enable SRIOV if you have SRIOV, if you want to use SRIOV. You have to enable it at the time you create the switch. You can't change it without deleting the switch later. Okay, so I'm going to say that I do want to have teaming available on the host. So I'm going to select the teaming option. And I'm going to add those two port profiles that I just created, my corp access and my corp trunk. So these are available in the logical switch, but they'll only get used on the host if I actually select to use it on the host. And then I'm going to add a number of virtual port profiles under a classification. So I'm going to add a classification for host management and say that the host management classification gets the host management port profile. And then I'm going to add a medium bandwidth just for general VM use. And then I'm going to mark the medium bandwidth one as the default. So if I don't specify classification when I create my VM or my template, then we'll use the medium bandwidth as the settings that VMs will get by default. Okay, so I'm going to finish the logical switch. So now the last thing I'm going to do is I'm going to actually create a virtual switch using this logical switch on the host. So I'm going to go up to my host. So I'm going to go to my host. I'll start with host 5. Go to the properties of it. You can see there are no virtual switches. I do have a number of physical adapters, though, in here. You can see I have 3 adapters. This Broadcom one isn't actually even connected, so it's disconnected, so it won't even get used. And then I have a dual port card that's both connected to the same network. These are in trunk mode. So I'm going to create a virtual switch to use that. So I'm going to do new virtual switch, new logical switch. And I only have one logical switch, so it automatically selected that. And then I'm going to say which adapters I want to connect to this virtual switch. By adding 2 adapters here, I'm essentially telling VMM to create a team. So we'll create the team for these adapters and apply the settings to it. And this is trunk mode, so I'm going to say that this is a trunk port, and so we'll automatically apply the necessary logical networks. Now, since these are the only 2 adapters that are enabled, I need to make sure that I create a management adapter as well so that I can still talk to the host. Management, and I check this box. What this box will do is it'll essentially tell VMM to copy the settings from one of the physical adapters into this virtual adapter so that if you're using DHCP, we'll get the same IP address and you'll maintain your connectivity. I'm going to tell us that this is connected to the management network. Then I'm going to add one more to also give myself corp access to this host directly so that if I want to RDP into it, I can do that. So I'm creating a second virtual adapter. You can see I select my corporate network, and you can see that we automatically applied the VLAN that I assigned to the corporate network. And I'm also going to give this a classification of medium bandwidth and hit OK. And so what's going to happen is we're going to go out and we're going to create a team. We're going to create the virtual switch, apply all the settings, and create the virtual adapter so we can continue to talk to the host. So we're going to be changing all the settings. We actually push a lot of these settings out in a batch to the agent on the host so that some of the operations, when you lose connectivity, will apply the next step from our agent on the host so that the connectivity will come back eventually. So I can do the same thing on my second host. I'm not going to do that now to save time. we'll move on. So that host, it'll take it a minute or two to run, and then it'll be ready to use. I can start to deploy VM, say that I want to connect the VM to Corp, and we'll apply the right settings automatically. All right, so now we have a logical switch. You can use the logical switch without any extensions. You can use it for managing your Hyper-V settings, for managing your uplink and basic settings of the switch. But really, the power of the logical switch really shines when you start to use switch extensions. That lets you essentially define what extensions you want in your logical switch. We'll talk to the manager of the extension. So the extensions will have a switch extension manager. This is a service that runs out on the network that has information about what these switch extensions are capable of. VMM will talk to it, find out what extensions it supports, and let you add those to your switch. We can then import port profiles from that extension manager as well. So the specific settings that extension can apply, we make available in the port profiles that we import for both virtual and uplinks. And then we'll actually go out and we'll install that extension on the host for you on every host that uses this logical switch. So we go out, we install the extension, and now we make sure that your hosts are configured consistently, have the right version of the extension out there, and have the same settings that you want over and over again. The other thing that we get from this virtual switch extension manager, though, are these externally isolated networks. Now, I talked about that at the very beginning. How we have this other type of isolation that we get from forwarding extensions in particular. What happens is when we talk to the extension manager, we'll import not connected logical networks, and within these logical networks, there's one site defined for each one of your externally isolated networks, and then you get a one-to-one mapping of VM network to those network sites to actually be able to use them with VMs. So I'm going to show you an example of how this is being used by NEC with their programmable flow SDN controller. This is an open flow controller. They're shipping the extension for Hyper-V now, and they're going to have the integration for VMM, I believe in a few months from now, will be available as well. Basically what I'm going to do is I'm going to create a tenant network using the NEC controller and then show how that gets used within VMM. I'm going to switch over to another demo environment. Oh, let me reconnect. Okay. So this is an environment that actually was set up by NEC to actually show this, this extension in use. Log in. So before I do anything, here's a VMM server. I'm going to zoom in a little bit so you can see we have the PF1000 extension manager added to VMM. This basically tells us what extensions we have available. And we have a logical switch that's configured to use that extension. So I go to my logical switches. You can see we have this TechEd switch, I believe. It's configured with the NEC extension enabled on this. So by enabling this, any virtual switch that we create to use this logical switch will automatically get the settings from this, will automatically get that extension installed on the host. Let me zoom back out. So what I'm going to do now is I'm going to use the NEC PowerShell to create a tenant network on the NEC controller, and then I'm going to go into VMM and actually realize that network as a VM network. I'm going to go into VMM. And we've imported a number of logical networks. This OpenFlow VTN network we imported it from the NEC extension manager. And this is what's going to be used to realize that network. I'm going to now go up to VMs and services, where I'm going to create a VM network using that logical network we imported. And this is my TechEd network. And since this is a not connected type of network, we have the options of what kind of isolation we want. I'm going to say this is user defined because I want to define my own address space. We'll then actually go out and tell, through our plugin model, we'll go out and tell the NEC controller what address space to use for this network. It's my subnet, and I believe it's 192.168.5.0/24. So I've created the VM network. We're going to go out and interact with the NEC controller to basically match that up with the VTN that I just created, so that essentially we'll assign VLAN 400 to this network. And then I'm going to create an IP pool for it as well, so that I can actually use it with my VMs. Go to gateway. Oops. One. And I'm just going to leave DNS blank for now. And so I have a couple of VMs that I've already created. They're currently not connected to anything. You can see here, oh, this is what I want. That's the other one. This VM, I can start doing a ping to another machine. The ping's not working, so I'm going to now connect it. So you can see the network's not connected. I'm going to go to this VM and actually connect it to the network. Oh, actually, here are my two VMs that I'm pinging from one to the other. I'm now connected to this network that I just created. Oops. Properties. And so I'm going to connect to this tenant network. Did connect. It's the TechEd network. I'm going to do it for one. I'm going to do it for the other one. So that job's going to run, and if everything works correctly, we should see the ping start going through. There it goes. So basically what we did is we created this tenant network, and we used the external isolation that's provided by the OpenFlow controller in NEC as programmable flow controller to be able to actually realize that network using an external method. So really expands on the isolation capabilities that we have in VMM and Windows Server. All right, so let's switch back. All right, so what's changed in R2 as far as forwarding extensions goes? Now, if you've looked at some of the extensions that are available now, one of the ones that stands out is the Cisco Nexus 1000V. It's an extension they just started shipping it, I believe, 2 weeks ago. They started shipping it for production use. And basically, it's a forwarding extension for Hyper-V. It's integrated with VMM. The problem with it, though, is that you have to choose between using the external isolation it provides or network virtualization. The two can't coexist in 2012 SP1 and Windows Server 2012. So in R2, we actually made a big effort working with our switch extension partners and made it so that these extensions can coexist with network virtualization. There were a number of changes that need to be made in Windows Server itself to be able to allow the network virtualization filter to be aware that these other externally isolated packets are coming through so that it wouldn't try to filter them out. And we need to make sure that we were aware of these other isolation mechanisms. At the same time, in VMM, we had to be more flexible in what we allowed these networks that we imported from the external source to be able to do. Because previously, we would just create a VM network on top of a site on a not connected network, as you see across the top. But in order to allow network virtualization to coexist with these extensions, we had to allow these extensions to supply connected logical networks as well, so that we could create a Hyper-V network virtualization network on top of a network that we imported from an extension manager. So essentially what we did is we converged the types of networks so that the logical networks, it doesn't matter whether it was created in VMM or we imported it from the switch extension. They're just logical networks. We still have the two types of connected or not connected, so we know if there are routes that exist. But they can now be used by the extension or by Hyper-V itself individually. So that if we import it from the extension manager, we can still create a Hyper-V network virtualization network, or the extension create its own type of isolated network. And this really enables other types of virtualization as well. So an extension could potentially even implement VXLAN. So I'm going to show you a quick demo of that. Okay, my VPN. we actually have a preview of some of the work that Cisco's been doing to make this possible. This is not shipping yet. It's just essentially showing you what will be possible when it is available. Okay, switch over. Need to reconnect because the VPN disconnected me. Okay, so in this environment, this is a 2012 R2 host with VMM 2012 R2. You can see in this environment I actually have a Cisco Nexus 1000 extension installed. So here's the Cisco Nexus 1000. It's added to this logical switch, and the hosts are actually using that logical switch as well on the host. So if I go to the properties, you can see each one has a single virtual switch, well, one that's used for all of my VM traffic. And I have a couple of VMs and a couple of tenant networks created. I have one network that's set up using Hyper-V network virtualization. Go to the properties of that. You can see it's set to use Hyper-V network virtualization on this. And I have another one that's set up to use the external isolation that's using just native traffic. So I believe this one's set up to use a VLAN, for example. And then I have a number of counters set up so that I can watch the traffic that's going through the virtual switch. So this one looks at the actual Hyper-V network virtualization packets that are going through the switch. So you can see there are a few keep alives that get sent through, but there's really very little traffic going through the switch right now that uses network virtualization. At the same time, I also have a couple of monitors set up on the virtual adapters on all my VMs, so you can see what traffic's going through each of the VM VNICs. So what I'm going to do is I'm going to start a file copy using the native VLAN. This is just going to copy a very large file. Ooh, whoops. Oh, yeah, ignore that. The first copy doesn't succeed because the file name isn't there. It's off by 1. But you can see that traffic is going through the switch. It's not network virtualization traffic because these counters aren't going, but it is sending a fair amount of traffic through the virtual switch. Now, if I go to my other VM that is configured to the network virtualization network, I can also do a copy with that one as well. We'll get that same error at the beginning. Just ignore that. And you can see now it's sending traffic as well at the same time as the native traffic is going. And you can see now these counters have started moving. So you can see now that it is sending virtualized traffic at the same time that non-virtualized traffic is going through the forwarding extension. The non-virtualized traffic is forwarded by the extension, and the virtualized traffic is forwarded by the Hyper-V network virtualization layer inside the switch. And so it really shows you that they can coexist, and we'll be enabling that in R2 when it's available. All right. Back over. All right, so what do we learn from this session? We learned that you should plan first. Plan everything ahead so that you can create things in VMM, your logical networks and your logical switches, the way they need to be created up front. Talked a lot about what's new in R2, the fact that we now have network managers that are independent of switch extensions. We have a number of plugins for IPAM and physical switches. We also have now a better integration with forwarding extensions is new in R2. What we'll be covering in part 2, that's coming up in about 35 minutes, is the ability to show you how you can actually now take this environment that I just set up to use basically very traditional VLANs and in the environment and actually enable network virtualization on top of that. So I can create tenant networks without actually creating new VLANs for each tenant. I'll talk about something that's new in Windows Server 2012, which is the network virtualization gateway. You have an inbox gateway for doing the connection between your virtualized networks and the outside world. There are a number of different modes and scenarios we've targeted for that gateway. And then, as I said earlier, I've got Charlie Wen coming in who will talk about the Windows Server side of things, how they actually implement the functionality in the gateway. And then I'm going to show you how that's actually tied all the way up and how we approached it as an entire scenario for hybrid networking to make sure we had the tenant experience exposed all the way through all the layers working together as essentially one Microsoft to bring all this together. So I encourage you to take a rest, come back in 30 minutes, and let's keep learning about VMM networking. Thanks.